This is the second segment on topic 2.3, and here we're going to talk about energy. And it's really pretty difficult to address work without talking about energy and vice versa. The actual definition of energy that we're going to use is the ability to do work or cause change. And so work is a transfer of energy. Energy is the ability to do work. All of our energy can be classified as either kinetic energy or potential energy. And kinetic energy is energy that's associated with motion, whether we're talking about motion on a macroscopic large scale or motion at the microscopic level of molecules. Kinetic energy deals with motion. Potential energy, on the other hand, is stored energy, and it's energy that an object has due to its position in some type of force field, whether it's gravitational, electric, magnetic. It's energy that is being stored because of that position. Now, while all types of energy are either kinetic or potential, we can also break them up into different forms. And some of these forms are listed here: mechanical, electromagnetic, which is our electromagnetic spectrum, UV, visible light, that type of energy, nuclear, chemical, thermal, electrical. And we're actually going to talk about all of these types of energy over the course of the year. But if we look at a couple here, for now we're primarily going to deal with mechanical. Mechanical is that macroscopic idea. We'll talk about gravitational energy. We'll talk about like a car rolling down the road. It's kinetic energy. We'll talk about elastic energy, which is the energy in rubber bands. These are all really kind of mechanical energy. And so if we start with gravitational potential energy, here is, again, that idea of position in a force field. And the force field that we're talking about with gravitational potential energy is, hopefully it's obvious, it's the gravitational field that for us at this point is established by the Earth. And so the Earth, because of its enormous mass, is exerting a gravitational force, and there's a field due to that gravitational force that surrounds the Earth. And as an object's position in that field changes, its gravitational potential energy changes. And we're going to really arbitrarily define where that potential energy starts zero and where it's non-zero. Because really what we're going to be looking at is and what we're more concerned about is the change in that gravitational potential energy. And so if we have some box on a table here, and let's for simplicity's sake say that it has a mass of 2 kilograms. We can say that this point right here is our reference of 0 joules of potential energy. Now, we said in the last set when we talked about work that work is equal to force times distance. And for gravitational potential energy, or for gravitational force, that's then mg, and our distance, our displacement here, is height. And so if the work done by gravity is equal to mgh, this then is also equal to the change in gravitational potential energy. And that's what GPE stands for, gravitational potential energy. Over here, we're going to just call it EP. And so when we're lifting some object or it's falling, that change in height is what's changing the gravitational potential energy. And so let's say I lift this box up to the ceiling, and that's about 2 meters. So I've lifted it up 2 meters. It has changed its position by 2 meters. Now, here it's mgh. Remember that mg is the force of gravity, and that's acting down our displacement is up. And so those are in opposite directions. So while I'm doing positive work on the box to lift it, gravity is doing negative work. And so it's going to be 9.8 times so it's going to be the mass of the box, which is 2 kilograms, times g, which is 9.8. This gives us the force of gravity acting on the box, times the change in height, or the displacement here, which is -2 meters. So if we're talking about the work done by gravity, it's going to be negative 39.2 joules. Now let's say we push it to the edge of the table and it falls off the edge of the table and lands on the ground. So there we have a change in height of 1 meter. But now, that doesn't show up well. Now if we look at the change in gravitational potential energy, again, we have our mass of 2 kilograms. We have our g of 9.8 meters per second squared. But now our displacement is in the same direction as the force of gravity, so it's a positive 1 meter. And so in this case, gravity has done positive work on it to the tune of 19.6 joules as it falls. And so now what we actually have happening here is when we lift the object up, we're increasing the gravitational potential energy. When the object falls, the gravitational potential energy is decreasing, but it's being converted into kinetic energy, and we see that as it travels faster. Now, as we just mentioned, and kind of from this slide, the important point to take is that, and it's unfortunately kind of hidden down here, the change in energy is what we're really focused on. It's what we're really talking about. And so it doesn't matter what your reference point is, the change in height is going to tell us about the change in the energy. And if we're lifting that object up, we're doing work on it. That's being stored as gravitational potential energy. As it falls, the work being done by gravity is converting that gravitational potential energy into kinetic energy.